Hey wild ducks. Welcome to our technology podcast. It's my pleasure to introduce the avatar of your host, Jerry Cuomo.
Thank you, RJ. You're once again looking at the inner workings of a quantum computer. Still pretty impressive, I must say. Today, Jerry continues his conversation from inside the IBM Research Lab with Scott Crowder from the IBM Quantum team. In part 2 of Thinking Quantum, they explore where quantum computing may begin moving from the research lab into the real world, and what that could mean for the future of computing. Now, back to Jerry and Scott.
We're back. Scott Crowder. And you're dialed into Wild Ducks. You're in the right place. And we're going to continue our chat about quantum computing here with Scott. So we talked about the 1940s moment. We talked about hardware and this kind of hybrid model of computing similar to GPUs, CPUs. We did a Sure algorithm reality check, and we just finished that. And now we're talking about the cybersecurity clock is ticking, and some of the actions you have to do. Let's with maybe that as a little bit of background. You recently, I believe, had the honor of being in front of Congress, was it? To speak at an event, which was it the House Oversight Committee or something like that? Something like that. And so when you talk to lawmakers, what's the one thing you wish an engineer would understand about real world impact? So I'm sure you've gotten all kinds of interesting questions from lawmakers. Yeah. But what are the things that you think are resonating that engineers should also worry about? So maybe we can start by, what were the questions that they had for you?
Yeah, so last time around was much more about the cybersecurity.
Okay.
Yeah. Which is basically, you need to start getting your stuff together.
Right, as you just said.
The other times I've been in front of Congress has been more about American competitiveness and kind of the flip side of it, which is like, what good can quantum computing do for society economically?
Okay.
Which is equally important. And I think I think the takeaway that y'all give the same takeaway I would give from lawmakers is that we're building more and more powerful systems. We're already at the point where our quantum computers can run quantum programs that you can't any longer run on the world's super. Right. But in order for the technology to have significant value, unlock, it's not that it's similar to AI. It's like you need to give this as a computational tool in the hands of algorithm developers, software developers, application developers to like unleash the innovation.
Yes. And we want to talk about that next, but I want you to keep going on your conversation with the lawmaker.
Yeah, and so there's a huge amount of extremely important reasons why the American government needs to fund basic research.
Absolutely.
But it also needs to include basic research on algorithm development. We're going to look at where the economic value is going to come from and who's going to capture it. Yeah, there might be an NVIDIA of the world who captures the hardware stuff, but most of the value is created in development.
That's right.
And what builds on top of that.
Yeah, the apps.
The apps, right.
Yeah.
Right, and the math underneath the apps, which probably gets a little less like visibility.
Yes.
But actually is the core.
That's right.
And you need to invest, therefore, in making the computation tools available to people, and you need to fund research into not just the hardware side, but also the other.
Okay, good. And now you've said something key there, which is not just invest in the core technology, the math and the applications around it. So let's talk about skills. I think part of my audience are students, and you're a sophomore, junior, maybe senior undergrad. So this is kind of where this question is going. Or maybe you're a professional who's been in some engineering field and now says, maybe it's time for me to jump the tracks and do this. What advice do you have for them? Think about getting hired. I see IBM recently put out in the press that they're doing some hiring. What's missing more often today when you're hiring? The math side, the ability to connect theory to real systems, physics. So what advice do you have?
Yeah, it's actually not physics.
Okay.
So it's good and bad news, right? So so I mean, I think that the big unicorn skill is a combination of math foundations and domain expertise.
Yes.
And the domain expertise is not just a traditional schooling thing. The math foundations is.
Mm-hmm.
So it's a combination of those. Right? So it could be chemistry, it could be financial services, optimization. It could be a whole host of
For the domain skills.
For the domain skills,
Yeah.
right? But it really does help to have, honestly, when I was in engineering student, et cetera, it tests my math foundation.
Yeah.
So definitely the math foundation was important. And then for the domain expertise, it is finding that mix of interest in using computation to push your domain forward. Right. So it's computational chemistry, optimization, data science. There's a whole bunch of fields that around that. But that's where most of the value patients come.
Yes, I agree with that.
And of course, we're going to hire people who are experts in chip design, to do on chips, or system architecture to do systems. So there's also a whole host of engineering skills that are getting used in the quantum industry.
Yeah.
Those are a little bit more traditional in some sense.
So one of the things, at least my first experience, being kind of person who's been around the block a few times in programming languages, application development frameworks, and things like that, and started in assembler and dabbled there, but C, C++, Java, now Python. And then I look at quantum frameworks where you're building circuits.
Yeah.
And it feels like I should have taken a class in electrical engineering too. Although things do even out pretty quickly. What's your view on programming languages? If you look at a circuit-based programming model versus the higher level programming models around today, where do you see it going? What is your favorite way to program a quantum computer, and where do you see that going?
Yeah, I think generative AI is changing that world significantly. I think that for the true optimization, there is you need to understand kind of how circuits work, that kind of thing. But you can program in C++, you can program in Python.
Right.
Pick your at this point it's pick your language of choice. I think the challenge is moving from, am I an expert at figuring out where to fix all my indentation in my Python program, to thinking about what problem does this math line up with solving.
Okay.
And it sounds
Yeah.
because we're even in quantum, we're at the point now where you can go into ChatGPT, Claude, whatever. And say, write me a program to measure the T1 coherence times on IBM Quantum. I want to pick the real back end. Write me the program and write me how do I get my token?
Yeah.
And what are the 5 steps I need to get my account and run the program?
Yeah.
It's
not like I've ever done anything like that.
Whoa. Let's pause the podcast for just 1 second right here. I actually did type in a similar prompt to what Scott just said in ChatGPT, and here's the results. It actually worked. Check it out.
And we can run the code in Google Colab right here. And in a nutshell, the program connects to a real IBM Quantum computer, and it visualizes how long each qubit reliably holds quantum information. And the graph plots those coherence times across processors' qubits. Well, there you have it. All right, let's rejoin the podcast.
Well, literally,
Yes, yes, it did quite well. Yeah.
So, I think the like value add shifts to like the innovation, like innovative thinking of like, how do I think about the problem?
That's right.
What kind
Okay.
of-
Hence the domain skills and all that.
Domain skills.
All right. So now with that, we're kind of coming to our last bit here. So you mentioned the 2030s being a high time for this. You work with partners and clients alike. Where do you see, what apps excite you that you've seen? What applications of quantum computing really excite you?
Two basic domains.
Yeah.
And one of them is simulating chemistry,
Okay.
and kind of the innovative one. So if you had asked me like last year, I would not have predicted we'd gotten this money. So
Yeah.
we're at the point now where Cleveland just announced like a couple days ago that they had simulated a 12,000 atom molecule.
Who is this?
Cleveland Clinic.
Cleveland Clinic. Yeah. Yeah.
12,000 atom molecule using quantum computers today.
Okay.
Right? And getting results that are comparable to the MRGs. That's not possible matter. So we're getting to the point now where they're taking problems of real biological relevance that people really want to do digital simulation on, to do digital twin kind of like stuff, and using a quantum computer to do it.
Wow.
Right? So that's today. That's not 2030s. That's today.
Okay.
Right? So we're at the point now where the quantum computing as a computational tool is a real tool for computational.
Okay.
The other kind of domain is the domain of optimization, which is more, it's pretty broad, but obviously if you're in like a financial services company, like there's a lot of things that if I could get 1% better, it's worth a lot of effort to get 1%.
Yes.
Right?
Yes. Yes.
So there's also interesting work going on there, which I think is very interesting. It's a lot more heuristic than the going to the chemistry side, which is very also like the same model.
Right. Right.
But I think similarly, people are starting to not have toy problems, but run problems that they're running today and A/B testing the quantum versus possible.
Nice.
Right? With the goal of cranking over the next couple of years, cranking up the difficulty on the problem to places they know the classical has more chance. So, for example, a number of constraints on a binary optimization problem.
With Cleveland Clinic and read articles, IBM and Google with some of their financial services clients. So you can see, let's say, jobs coming for both technology sector, i.e. the developing companies who are developing, but also the who's who of banks, insurance. Yeah. So great. This is encouraging. I mean, there's been a bit of a lull in the software market, and hopefully this is another spark to come. So you've been a spark on multiple fronts here, Scott. So I want to pause to thank you. Thank you for having me at such a esteemed place and such a place near and dear to my heart. Thank you for joining us here today, and good luck. Okay.
Hope you enjoyed this conversation with Scott Crowder from the IBM Quantum team. Across these two episodes, one thing came through clearly. Quantum computing is starting to move beyond research demos and into practical problem solving, creating new opportunities for builders, software engineers, scientists, and entire industries. And yes, the rumors are true. Jerry is at work on a new book, Think Quantum. In fact, you may even see parts of this conversation and some of the ideas discussed here make their way into future chapters. If you'd like early access to draft chapters, updates, and behind-the-scenes material as the book evolves, visit wildducks.us and join the free early access list. See you again soon,